Yes,
Good
sir.
night. Good night, everyone.
Good
Welcome
night,
to
sir.
another class meeting. Please remember our rules. You're going to keep your cameras off for privacy purposes. Make sure that you have your pen and paper. And we want to welcome tonight Shade. Shade, are you there?
Yes, sir.
What are you doing?
Fine, sir.
All right, so since you are new, we'll start with you.
Mhm.
We have a number here. Call this number for me, please.
1,789.
And we're going to add to that what?
94.
And
105.
and
6.
okay, so let's add now. 6 and the 4 would be what?
10.
10 and the 9 would be what?
19.
19 and the 5 would give us what?
24.
Okay, so I'm going to write what? 4
24.
and carry what?
The 2.
Okay, so the 2 and the 8 would be what?
10.
10 and the 9.
19.
So I'm going to write 9 and carry.
1.
Okay, so 7 and 2 would give us what?
9.
And I have nothing to do with the 1 but bring it back. What's my answer, sir?
1,994.
Excellent. So we move to Corey. Read for me, Corey.
Sir, it would be 0.01
Corey, we're getting a
times
feedback loop.
0.13.
All right. So we need to remember what? When we're multiplying decimals.
Decimal places.
You don't pay attention to the decimal point first.
Okay, we're going to count off the decimal places. So here, how many decimal places we have? How many places?
Sir, 4 decimal places.
We have 2 decimal places here. And we have 2
2
decimal places here. When we add that, our answer needs to have how many decimal places? How many? Not hearing you. How many?
Sir, it would be 3 times what?
No. How many decimal places our answer needs to have?
4 places,
Okay.
sir.
So let's multiply. 1 times 3 would give us what?
3.
1 times 1 will give us?
1.
And 1 times 0?
0.
Okay. Do I need to continue any further?
On a,
I have 0 here. Do I need to use this 0?
yes, sir.
No, sir.
Okay, all right. So placeholder 0 times 0, 0 times 3, 0, 0 times.
Just get one lang
Zero.
yan.
All right. So we're going to move to this one. So we need 2 placeholders.
Sir,
0
because
times
of how
3,
I
0.
multiply.
0 times 1, 0. 0 times 0, 0. We're going to add. We get.
Sir, I just like writing all of the zeros to make it efficient. Even though there's a shorter way for me.
All right. How many decimal places we need again?
4.
1, 2,
2,
3,
3,
4. So my answer will be 0 0.0013. This is correct. So let's move on. Sally, this one is yours. Read for me. What does it say?
3 minus 0.976.
So here I have my 3. I have minus the 0.976. I'm missing a few what?
Placeholders.
Placeholders and my decimal
Place.
point. All right, help me now. Can I take 6 from 0?
No, sir.
What am I going to need to do?
I will just take 1 from the 3.
Can I take it from here?
No, sir, because
Here?
we have nothing. No,
Okay.
sir.
So when I take 1 from the 3, it leaves me with what?
2.
I put it here, and I start that whole process over. And now I'm going to borrow from,
10,
okay, leaving with 9.
9,
Repeat, leaving with 9, having it here. So 6 from 10 will leave me with,
4,
because 4 and 6 makes
10,
7 from 9 will leave me with,
2,
because 2 and 7 makes
9,
9 from 9 will leave me with
nothing, 0,
0.
0. Decimal point under,
point,
and we bring down or,
2.
because if I have 2 dumplings and I don't eat any of them, then I will have my dumplings same way. Right?
So the answer is 2.024.
All right, excellent. TC, this is yours. What is the value of the underlined digit? Call the number first for me, please.
1948.
What number is underlined?
9, sir.
Okay, so what's the value of that? And when we're talking about the value here, I want the true value.
Sir, 900, sir.
All right, let's go with our place value. 8 is in the what place?
Ones place.
What about the 10?
Tens place.
And the 9?
Hundreds.
And the 1?
Thousands.
Thousands.
Okay, so this would actually break out to be something like this non-expanded form. This is 1 multiplied by 1.
Thousand.
9 multiplied by 1. 100. 4 multiplied by 10. And
8 by 1.
8 multiplied by 1. Okay.
Yes, sir. Sir, in the 6M group, Akib is asking, what are you talking about when you say the feature, the chat feature?
If there is a,
Sir,
he can leave.
On YouTube.
He can leave comments.
Yes, sir.
Yeah, on YouTube. So we have 1,000 plus 900 plus 40 plus 8. This is how we end up back with our number 1,948. So we have moved here into what? Expanded form, and we know exactly what that means, and we bring it all the way back to the number. All right.
Yes, sir.
Remember, place value. We have true value, we have place value, and face value.
Face value.
Also, that's not face value at all. Face value. All right.
Yes, sir.
Let's shade back to you now. Read for me, sir.
Read for me, sir.
You ready, sir?
Come in, sir. Come in, sir. Yes, sir.
All right, here we have a problem. We're having a division issue here. We have a decimal. We need to divide it by a whole number. Tell me what I need to do and where I need to put these things.
You put the 5 on the outside, sir.
5 outside. What needs to go inside?
71.5.
71.5. All right. This problem can be represented also like this. This is what way is this set out? Start with H.
Horizontal.
Horizontally. But the same division problem can be set out how?
Vertically.
Vertically. All right. All right. So let's go over to this now. So we need to remember, hold on, that every what?
Dog must swim back.
Dog must swim back.
Back.
That means what? We're going to estimate, which means to what? Make a guess. We're going to what? Divide. Gonna what? Multiply, subtract, and bring down.
Bring down.
All right, so we're sure of that now. Those are the key things to remember. Okay, Shade, 5 into 7 goes how many times?
1 time.
Hold on, there's something we need to do before we do anything else with the division problem set out like that. What we need to do?
Estimate.
No. Even before that. Once we have a decimal there, what we need to do?
Ignore it, sir.
Somebody throw my lifeline, please. What do we need to do? Hint, it has to do something with the decimal point.
Sir, you bring up the decimal point. If
We need to bring up the decimal point.
I was saying.
Oh, we didn't hear you clearly at all. All right, so Shade, ready again.
Muted because I was talking to my sister.
Okay, all right, cool. 5 into 7, how many times, Shade?
1 time.
Okay, so we move on now to the multiplying stage. So we're going to say 1 times 5 would give me what?
5.
All right, then we move to subtraction. What do we have?
5 from
7 things we take out. Yes. Answer?
2.
Okay, 2. What do we need to do next?
Bring down the 1.
So what we end up with here now?
21.
Okay, so 5 into 21 would go how many times?
4 times.
Okay, so 4 5s would give us what?
20.
And if we take 20 from 21, we have what left?
1.
All right, so we're going to bring down the 5. And this will be now 15. And 5 into 15.
3 times.
And 3 5s will give us what?
15.
When we subtract 15 from 15, we end up with what?
0.
Okay, so we end up with a what? What we call this number at the top here now? It have a special name. What's that?
Quotient, sir.
Very good. And the 5 would be what? Special name?
Divisor.
Divisor.
What would it be?
Divisor.
Good. And the number inside is called what?
The dividend.
Excellent. How do we check our answer now to make sure that it's correct?
By multiplying, sir.
Multiplying what?
5 by 14.3.
Okay, use the term, sir. We're going to multiply the divisor and the
Quotient.
to get back the
Division.
to get back the dividend. All right, so let's set that. Let's see if we can set that out. So 14.3 multiplied by 5. How many places of decimal I have?
1.
So my answer should have how many places of decimal when I'm done?
1.
Okay, so 5 3s would give you what, sir?
15.
Write 5. This is how 15 looks. We're going to write 5 and carry 1. 5 4s would be what?
20.
20 and 1 would be what?
21.
So we're going to write 1 and carry 2.
2.
5 1s and the 2.
7.
How many decimal places I need in the answer?
1.
So I counting from the right, 1 place.
1.
So my answer will be 71.5. What's the answer, sir?
71.5.
And if I get back this, then I know that it is correct.
Yes, sir.
Very good. All right, so let me see who's next. Yes, Corey, let's go. Corey, which digit has the greatest value in this number here? What's the number, please?
Sir, 1,529.
Which value are they talking about here? Is it the face value, The place value or the true value that they're talking about?
The place value.
No.
Okay, true value.
All right, good. So let's see if we can break this into its pieces now. So this one is, well, 9 would be in what column?
Sir, that
9
would be the ones place.
ones. 2.
That would be the tens place.
All right. 5.
Thousands. No, hundreds
Huh?
place. Hundreds place.
Okay. You're frightened, me man. Sure. And and the
Thousands.
1 would be in the thousands place. All right. So 1 would be 1 multiplied by 1,000
5 would be 5
plus.
multiplied by 100.
All right. Keep going.
Then the 2 would be 2 multiplied by 10.
Okay.
And 9 would be 9 multiplied by 1.
9 multiplied by 1. All right. So this one's there, here, and here. And we want to know the value of the 1. So it's 1 times 1,000, which would be 1,000. 5 times 500
plus
plus
20
20 plus 9. And what they asked us for was the one with the greatest value, which is 1. All right.
Yes, sir.
Okay. Let's see who's next. Tally,
Talia.
Yes, sir.
you got one like this last night already. Call this number for me, please.
Sir, 1,200,000. Wait, sir.
Sir, may I throw a lifeline for Tally?
Not yet. Give her some more time.
Sir, 1,200,111.
The middle part wasn't so clear. Go again with it.
Sir, 1,200,000. Sir, 1,201,211.
That 201 is what?
Sir, what do you mean by 201 is what?
Because you didn't tell me what it was. You just said 201.
Sir, 201,000.
Okay, that's completely different now. So that's correct. Again, this is a place value type thing. So we have our ones. Then to the left of that, we have what? Tens.
Sir,
to the left of that, hundreds. These 3 hundred tens and ones. Then the next 3 will be thousands. We will have source of 1,000. Then we have what? 10,000. Then we have 100,000. Then we have million. Then we have tens of millions, hundreds of millions, and so on. So in this case, we have only what? 1 million. We have 201 thousands. Then we have 211. Clear?
Yes, sir.
What do we use to separate the major chunks of the number again?
Sir, comma.
Okay. So every time we have 3 digits,
It's a part of language arts.
all right, very good. So we're making that link here as well. So we go over to TC. TC?
Yes, sir.
Which shows only improper fractions. Let's pay attention to the word only and improper fraction. So let's go back to our definition of an improper fraction. What's an improper fraction?
An improper fraction is a fraction that an improper fraction is a fraction that the numerator is bigger, larger than the denominator, or equal to the same.
Okay. So let's polish up that response a little better. So an improper fraction is one in which the numerator is greater than or equal to the denominator. So let's examine them. We have 1, 2, 3, 4 options here. Let's start with this one. If this were option A, this is B, this one is C, and this is D. Let's look at option A first. 3/4, proper or improper?
Proper.
All right, so this out of it already. So once any part of this is wrong, then all of this is wrong. Clear? 6/8,
Yes, sir.
proper. All right. Let's go over to option B. What's that? Proper
Sir,
or
7 over.
improper?
Proper,
Yes?
sir.
Proper. 3/4, proper. 2/5,
Proper.
proper. 5/7, proper.
Proper.
Let's go over to C.
Proper, sir.
No, I want you to call it so I can hear what you're saying.
Sir, proper, sir.
What's the name of this fraction?
Oh, 2/3, sir.
Very good. And 2/3 is what? Proper, so that can't be in it. 2/3 is proper, so that can't be in it. Next one, say the next one.
3/4, sir.
No, man, 3/2.
Oh, no. 3/2, sir.
Or 3/2. So
Yes, sir.
this one is improper, but 3/4 is what?
Proper.
3/4, okay. And 3/5 is
Proper.
proper. So we rule out A, we rule out B, we rule out C. But we still have to check D to make sure that it's correct. 5/3.
Improper.
So this one is good. 3/2.
Improper.
Good. 7/5.
Improper.
What's the last one? What you call this one?
9/8.
And that one is good. So which one is the answer?
Sir, D, sir.
Okay, so option D would be the answer. So for this question, we needed to be aware of what is a proper fraction versus an improper fraction. Cool?
Yes, sir.
No questions regarding that one, right, everybody?
Yes,
Yes, sir.
Okay, so we are back to Corey. Corey, read for me, please.
Sir,
Ish.
shows $60,002.
Okay, so this is a dollars and cents question. Tell me the answer, please.
Sir, it would be
Let's
C.
say that this is A, this is B, this is C, and this is D.
It would be C.
So you say that it's C, as in this one.
Yes, sir.
Yes, sir.
Okay, let's do place value here because we have place value for dollars and cents as well. So what would this column represent?
Sir, that would be the ones column.
Ones. Hello, look over
Sir,
here, so
oh,
please.
decimal.
Oh, Lord have mercy. Go ahead.
Sir, that would be the hundreds.
Very good. Hundreds. How many cents make a dollar?
100.
Okay, very good. So the column that is to the left of the hundreds column would be the what?
That would be the thousandths.
Somebody wants to help her with that one? To the left, to the left.
Okay.
Yes, sir.
Tenths.
Sir, to
Okay.
the left of sir, I
Left
cannot.
of the left of the hundreds column, we have the tens. Then we have the
Yes, sir.
decimal point, and to the left of the decimal point, it would be what?
Whole numbers.
Yes. Which one of the whole numbers here?
Ones.
Okay, ones. To the left of the ones, we would have what?
Tens.
Tens. To the left of tens, we have what?
Hundreds.
Hundreds. To the left of hundreds, we have what?
Thousands.
To the left of thousands, we would have what?
Tens
Ten.
of thousands.
Tens of thousands. And to the left of
Hundreds
tens
of
of
thousands.
hundreds of thousands. All right, good.
Sir, why is it that when someone is speaking, the screen comes off of what you are doing and goes on to the person?
That's what you're seeing?
Yes, sir. Sir, If Corey is talking, sir, it comes off and show her profile picture, and if Tessie is talking, it comes off and show the green thing, sir, and if Shade is talking, it comes off and it acts the same way.
All right, no problem. I don't think that is being recorded that way though, but it's just to help us to identify who's the person speaking. Okay.
Sir, it's not doing it for me, but I'm hearing people's echoes.
Okay, that's why we have to use the earphones as best as possible to cut down on that. All right.
Yes,
All
sir.
right. Let's go back to tally. How many odd numbers are between 50 and 64? So what's the first step for this?
Sir,
What would I have to do?
so you have to write all
Okay, so 50, 51, 52, 53, 54, 55, 56, 57, 58, 59. What comes after 59 again?
60.
Oh, okay. 60, 61, 62,
62, 63.
60. No, this one too close. Give it a little more space, man. Sure.
Yes, sir.
63,
64.
64. First step, they said between. That means I cannot use what?
so you
Can't
can
use 50 and I
And
cannot
can't
use 60,
64.
64 because they said between those numbers. So I can use from 51 all the way down to 60.
63.
3.
All right. So odd numbers now tell you what are odd numbers.
sir, odd numbers are numbers that cannot be divided.
Good night, sir.
All right. Hold on, Tony. Hang on, Tony. We're talking. Hold on a bit. So it cannot be exactly divided by 2. It leaves a remainder. Okay.
Yes.
Odd numbers also. Somebody has to work on that echo. They have to turn the mic down completely.
Sir, I am having a problem, sir. Anytime somebody's talking, the screen comes off and I cannot get it back on.
I'm not certain why that is happening, but
I have to how many times for it to come back. Even if I am talking, it's at the same way.
no. I'm not certain what's happening there.
What is that pitter patter in the background?
Okay, so let's go. Tally, odd numbers end with what digits, please? Tell me the digits that an odd number will have.
Sir, 1, 3,
Mm-hmm.
5, 7, or 9.
Okay. So 51. Is 51 odd?
What you said, sir?
51, odd or even?
Sir, odd.
Hold on, let's just complete this. Even so if these are odd, even numbers will end with what?
0, 2, 4, 6, or
0,
8.
2, 4, 6, and 8. So 51, odd or even?
Sir, 51 is odd.
Okay. 52, odd or even? 52?
Sir, even.
Somebody's background is come on, people. 53, odd or even?
Odd.
54?
54 is even.
Can I use that one? 55?
Sir, 55 is odd.
Odd. 56?
56 is
Can I use that one? 57?
57 is odd.
Odd. Very good. 58?
Even.
Can I use that one? 59?
Odd.
60?
Even.
Can I use that one? 61?
Odd.
62?
Even.
And 63? So let's look at how many we have that we can use, because they said how many. How many? 1, 2, 3, 4, 5, 6, 7. So answer equals 7. Who's next? TC, what is the reciprocal of 5¼
Sir, 5 and 1, 4 over 1, sir.
Pardon me?
So you're going to change the fraction into improper fraction, sir.
So we're going to change this mixed number to an improper fraction. How do I do that?
Times the denominator by the whole number, and the answer you get added by the numerator.
So tell me, what is 5¼ as a improper fraction?
21 over
21 over 4.
21 over 4. So what will be the
Reciprocal.
reciprocal of 21 over 4?
4 over 21.
So the reciprocal is 4 over 21. Right? Amelia, turn your headphone, turn your speaker down, please.
Yes, sir.
All right. So, and Amelia, if you have headphones or earphones, please use them.
Yes, sir.
So here we have the reciprocal, and we need to remember that the reciprocal is that number that when we use it to multiply the original fraction will result in 1. So let's look at 21 over 4, and we multiply that by 4 over 21. We'll see that what? 4 can go into itself one time, 4 can go into 4 one time, 21 can go into itself one time, and 21 can go into 21 one time. Then we say numerator by numerator. So this will be 1 times 1 over denominator by denominator, 1 times 1. So 1 times 1, 1 over 1. Any number divided by 1 remains the same.
Same.
Okay. So we know that this is correct. We know that what? 4 over 21 is the correct answer. All right, so we go back now to Shade.
Yes, sir.
It says arrange the following fractions in descending order. What does descending mean?
Going down, sir.
Going down from where to where?
From highest to lowest.
Okay, so descending would be looking like this. So we're going from large to small, or highest to lowest. How will we be able to know which of these fractions is the highest and which one is the lowest?
By finding the LCM.
Okay, finding the LCM or the lowest common multiple.
Multiple.
All right. So what's the LCM of 2, 6, 12, and 4?
12.
12. Let's see if we could do that though by prime factorization for those of us who might not remember. What number do I start with?
2.
2 can go into 2.
1 time.
Hold on a little, Tally. 2 into 6.
3 times.
2 into 12.
6 times.
2 into 4.
2 times.
Which number do I continue with?
2.
Okay, I'm going to use 2 until all even numbers are.
3. And 1. And then we use 3 again.
So did you mute your microphone?
Sir is on mute.
Hearing me, guys?
Yes, sir.
Tally, why you mute, sir?
Sir,
I don't
just
know
mute.
what is happening to this tablet.
Sir, you're muted again.
Sir, I don't know what is happening to the tablet.
Okay, guys, please, if you mute me, that's not gonna work.
Sir is with tablet.
All right, well, try to keep your hands off it for now. All right, ready. So let's go. So where were we now, Shade? 3 into 3 would go
1 time.
and we're going to care about the 1. Form our L, right? LCM, multiply everything outside. So this would be 1, 1 times 3, 3, 3 times 2,
6.
and 6 times 2.
12.
So the LCM is 12. Let's use that 12 here. Okay, Shade, help me now. What do I need to do next?
2 into 12.
You know what? Let me do it the other way that we saw the other day. So we're going to use 12. And 2 into 12 would go?
6 times.
And 6 times 1 would give us?
6.
So the equivalent fraction for a half would be what?
6 12.
All right, so we're using LCM of 12. 6 into 12 will go?
2 times.
And 2 times 4 would give us?
8.
So the equivalent fraction for 6 would be 8 12s.
12.
All right, LCM 12. 12 into 12.
1 time.
Use that factor of 1 and multiply the numerator and we get back what?
7.
All right, so 12 again. And 4 into 12.
3 times.
And 3 times 3 will give us? All right. Now we need to arrange them in not ascending, in descending order from the largest to the smallest. So we're going to rewrite this now based on the fraction that they gave. So which one is the largest, Shade?
3/4.
Or 3/4. That one comes first.
Yes, sir.
Then after 9, what will come after 9?
4/6.
4/6. 4/6. Then
7. 7 over 12.
7 12s. And lastly, we would have what?
Half.
6 12s. No, a half.
No, man, a half. Very good, because we have to use the ones that they gave.
Yes, sir.
So if we were to arrange, we could also say here that we are what?
Comparing.
Comparing what?
Fractions.
We're comparing fractions. And whenever we need to compare fractions, we need to find the equivalent fraction. We need to find the equivalent denominator or LCM or LCD, lowest common denominator that's there. All right?
Yes, sir.
All clear on that one?
Yes, sir.
Yes, sir.
All right, so let's move on. Amelia, this one is yours.
Yes, sir.
Your phone have a buzz in it, man. All right, ready? Here we have a sequencing question. And remember that in a sequencing question, there's a pattern or there's a rule that we need to pay attention to. Amelia, read what we have here.
Sir, it says complete the square. 2.
We have, look at this triangle, 2 square. Square, 4 triangle. Then what do we have, Amelia?
Triangle 6 8.
Something
Square.
is missing. Yes. Then what do we need here?
Triangle.
What do we have here?
Triangle 10 square.
Every time I move over to the other one, do I keep starting with a triangle or does it change?
It changed.
All right. So let me see. I start with a triangle, but I end with a what?
Square.
And if I start with a square, I end with a?
Triangle.
And if I start with a triangle, I end with a?
Square.
So what do I need to start with in this one?
A square.
For real? Look at the ending. This one ends with a, then
Square.
this one ends with a triangle.
Triangle.
This one ends with a square.
Square.
This one ends with a square.
Triangle.
So can we use that?
Yes. What I said, sir?
Let me just double check this to make sure I have this right. Pick your answer in the meantime. I'm just gonna make sure that I have this correct.
Yes, sir.
Right.
Excuse me, sir.
Man, I say nothing. They're gone.
Sir, just on mute.
No? They're on mute.
Amelia, what is your answer?
Triangle X.
Yes, way. Going.
Mute, please.
Go
Sir,
now.
on mute.
Yeah. Come
Once sir's finished, can anybody send me number 9's question if they're writing
All
it
right.
down? Because I will know
Ready.
everything.
So let's go. It's correct. It's correct as it is.
Yes, sir.
So what's the answer?
D.
You think it's D? Let's see. Why wouldn't you use A or B?
Sir, because it is counting by 2.
All right. So we can't use 7. So we know those two are out. Let's look
Yes,
at
sir.
C. It
Sir,
starts. Why we can't use C? You said that we should use D. Why? What? What's the reasoning?
sir, because because but you have triangle 2, square 5, 4, square 4 triangle, and triangle 6 square. Now you're going to put 8 square, 8 triangle.
All right. Let's see. So we
Because you
start.
ended with a square, so you
So we
start
need
with
to start with a triangle. You see that?
no.
Every time we start, we change. So we have triangle here. We start with square. Then we start with triangle. Now we're gonna start with a what?
Square, triangle.
Yeah. So we're gonna start with this one, and we end up with 8 and. All right. So it looks like D is the correct answer, right?
Yes, sir.
So based on the pattern that we have, which answer we have?
D.
D. All right.
Yes,
So here
sir.
we have the pattern. We are looking at two things to determine this. We're looking at the movement of the numerals in the sequence. So we know that we're going up by 2. Then we look at the what we start with. So we keep changing. So we start with the what? Triangle. Then we go to the square. Then we go to the triangle. So we need to go back to what? Square. So this is the one that we would use. All right.
Yes, sir.
Okay. I'm not certain why this is like this. Hold on. Let me see who's next.
Turner should be next.
Yeah, Tony should be next.
Sir Akeem asked, Sir, didn't you send Akeem the link to watch it on YouTube?
Yes, we did.
Sir, he's asking me for the link again.
All right, just tell him to watch on YouTube. All right, ready. Tony, this one is yours.
Yes, sir.
Let's go.
3, 5.
What? Let's look at set A. Set
Yes,
A
sir.
has 3, 5, 7, and 9. Set A is best described as
Odd numbers, sir.
not counting.
No, sir, it's not counting.
Where counting numbers start.
Sir, at 1, sir.
Okay. Even numbers.
No, sir.
Why?
Sir, because even numbers are 2, 4, 6, 8,
Even numbers end with 0, 2, 4, 6, and 8. All right.
Yes, sir.
Odd numbers now end with
Sir. Sir, prime numbers, sir. Sir, prime numbers end with.
not
Sir,
prime, odd.
Odd numbers end with 1, 3, 5, 7, or 9.
All right, cool. And prime numbers now have only two factors.
Yes, sir.
Two factors.
1 and
One
itself.
and itself. All right. So this one is best described as odd. Let's go back now to Corey. Corey.
Sir, it would be the ratio is 20 to 36 as a ratio is equivalent to 9, 95, 90, and 20 to 9.
Okay, answer.
Sir, I would say 5 to 9.
Okay, so we're going to change this ratio to a fraction.
Sir, wasn't it a question from last night?
Yes, putting it back there. So let's reduce as best as we can. What number could we use?
Sir, you would use 5.
5 into 20 goes
5 into 20 to actually go.
how many times?
It should actually go
25
4
times.
Sir, to go 4 times.
Okay, and
9 times.
5 into 36.
Sir, you put
Sir,
the
9
wrong
times.
answer.
Sir, it is.
We're using the wrong one.
4
Exactly,
Go.
sir.
Sir, it
Would
is.
be
goes 9.
4. 4
It's
into
5
20 would go
times.
Yes, sir. 4
5.
times.
Yes, and 4 into 36 would go
9 times.
9
9
times.
times.
We get 5 over 9, and we're going to change this fraction now back to a ratio by saying that it is what?
5 to 9.
5
to
to
9.
9.
All right. Who's next? Tally, back to you. We have 349 and we want to put that in exponential form. Let's remember this. 10 to the first power, 10 to 0 power is 1. 10 to the first power is what?
10
10 to the first power? Not hearing you, Tally.
Sir, you're talking to me?
Yeah, Talia.
Yes, sir. Oh. Sir, 10 to the first power is 10.
10 to the second power would be what?
Sir, 20.
No, not 20.
Sir,
Means that we need to have 2 zeros in the number.
100.
100, because this really means what? 10 multiplied by 10.
Yes, sir.
Okay. 10 to the third power?
1000.
1000, because it has 3 zeros. 10 to the fourth power?
Sir,
Sir, lifeline.
sir, no. Sir, it will be 10,000.
Okay. 10 to the fifth power?
10,000.
And 10 to
And
the
a
sixth
million.
power? And this would be 1 million.
1 million.
All right. Remember, exponential form, the number, if we have 2 to the third power, this number is called the base. And the small one that's on the shoulder of the other number, this one is called the exponent. It tells us how many times the base should be multiplied. So 2 to the third power, or 2 cubed, actually means 2 times 2 times 2, which is 2 2's 4, and 4 times 2. So 2 to the third power is actually 8. Okay, Tali, now that we have reviewed that, let's go to 349. What does this, how do we write this out?
Sir,
Come, let's go place value. 300 is actually what? 3 times 100 plus
plus 4
4
times
times 10. And then what? 9 times 1. All right. Now, what is 100 in terms of exponential form here?
So 10 to the second power.
So it's 3 times 10 squared plus 4 times. What's 10?
4 times
10 to the first power plus 9 times
1.
No, not 1.
So 0.
10 to the, all right, so 0 power. So are we seeing this? We haven't started doing these in class yet, but we're figuring them out. All right.
Also in lessons.
So why is it 10 to the?
Because that's just the rule. 10 to the 0 power actually represents 1. So any number to the 0 power is 1.
Yes, sir.
If we find a better way of explaining that, then fine. But for now, that's the rule. All right, let's go. TC, back to you. Prime factors of 36. We have 2 methods of doing that. We have the factor tree method and the ladder method. Let's go through both of those.
Yes, sir.
Factor tree, sir?
36, sir.
Yes. And we're going to break this out into what?
3 by 1, sir, because it
No, man. What two factors could we multiply to get 36?
Sir,
3 times
18.
1, sir.
3 times 1 can't give us 36.
Ah, sir, 2 times 18,
Sir,
sir, or 4 times
2
9,
times 2 times 18.
times
or 4
9.
times.
Okay. So
Sir, can use 2 again.
keep 2 because it's what? Prime. And we can break out the 18
9.
into what?
9, sir.
9.
2 times 9.
9.
What do we have now as the prime factors here? 2, 2.
2.
Can we break out 9?
Yes, sir. 3
Yes,
times
We
sir,
could
3,
break
using
this out into
3.
what?
3
3
times
3
times
3.
times
3.
3.
So 2 times, keep this one, 2. So now we have 2 times 2 times 3 times 3.
Yes, sir.
Let's go with the ladder. 36. Let's go with 2. 2 into 36.
18 times, sir.
2 into 18.
9 times.
9 times.
3 into 9.
3 times.
3 into
Times
3.
1.
1 time.
So the prime factors of 36 would be
2
2.
times
4.
2.
No, 2 times 3. We don't. 2 and 3 rather, not
Yes, sir.
times. 2 and 3. Right? We don't need to multiply those. We're not stating them to give us back the 36. We're stating what they are. So we're just grouping these, and we have 2 and 3.
Yes, sir.
Let's see. Shade, back to you. Are you there?
Yes, sir.
Read this problem for me.
72 pencils are shared equally among 6 students.
Show that.
Show that as an expression.
So which one of these would show that situation?
72 divided by 6.
All right, because we're using the word share, so we'd use this one. Any issues with that?
No, sir.
We need to remember what is an expression versus what is an equation. In an equation, what do we have?
Equal sign, sir.
Equal sign. So 2n is equal to 12. This is an equation versus an expression.
Yes, sir.
All right, we're winding down now. Going back to Amelia. Show the following using sets. What would I need to do, Amelia?
Sir,
What would I need to do now?
draw the Venn diagram.
Very good. I'm putting set what?
A.
I need set B as well, not true?
Yes, sir.
Is there anything common? Do I need to have an area of overlap?
Yes, sir.
Okay, so let's see. And this is set what?
B.
All right, help me to put in the elements or the members of set A. What do I need to put inside?
2,
2.
3,
Okay, so right 3,
4,
4.
6.
Okay. Anything that I need to put in set B?
Yes, sir.
Is there any other correction I need to make before I move on?
No, sir.
Okay, if you think so, I can tell you that there's one there already, but let's go on. So where do I put what? Yeah, help me to put these in now. What do I need to write?
3,
Okay, 3,
5,
5,
7,
7,
9.
9. I noticed already that I have 3 here and 3 here. What do
Yes,
I need
sir.
to do with those?
Sir, you put it where put the three where it is overlapped.
Where it overlaps. So do I need the 3 in here and need the 3 there?
No, sir.
Okay, so take it out. All right. Okay, so that's that.
Yes, sir.
No, it says show the following. Still with you, Amelia. Show the following using the sets. What is A union B? Just tell me what I need to have. This means that I'm going to do what? List all the elements in set A and all the elements in set B.
Yes, sir.
So A union B equals, what do I need to have?
3.
We have any other number?
No,
Any lower
sir.
number than that? Any number lower than that?
2.
Yes, sir. 2,
All right, so 2 is there.
3,
3 is there.
4,
4 is there.
5,
5 is there.
6,
6,
7,
7 is there.
and 9.
9. All right.
Yes, sir.
Tell me this. Why didn't I write 3 2 times?
Sir, because 3 because 3 are already what a 3 is already there.
Okay, so we don't need to repeat numbers that appear in both sets once we write it one time.
Yes,
All right.
sir.
Okay, almost done. Let's see, who's this? Tony, this one is yours. Is she there? Not hearing her. So let's go to Corey then. Corey,
That.
If n take away 3 and 7/8 equals 7, how would you find n?
would
I
I
and
would I would I
7/8.
add 7/8 to both sides? Would I subtract 7/8 from both sides? Would I multiply both sides by 3 and 7/8? Would I divide both sides by 3 and 7/8?
Sir, I'm not sure.
Not sure. All right.
Mm-mm.
Let's do this. If I have 2n is equal to 8, how do I find this? How do I find n?
Sir, the screen is frozen, so I can't really see what you're doing.
Okay. We would need to divide one side by 2 to get
Yes,
rid of the
sir.
2, divide the other side by 2. So we end up now with n being equal to 4. We're going to
4.
substitute, yes, substitute 4 wherever we have n. We're going to test to see if that is right. So 2n would be equal to 8. So this would be 2 times 4 should be equal to 8. So we have 8 on the left hand side, and we have 8 on the right hand side, and we know that that is what? Balanced. Okay.
Yes, sir.
All right. So what we
Yes,
do to
sir.
one side, we need to do it to the other side. Let's go back and see if we have it. We have n minus 3 and 7/8 being equal to 7. If I want to get n by itself, what would I need to do? Anybody else?
Sir, me
Go ahead, sir.
add
Okay, so we're going to what? Add 3 and 7/8 to what? Both sides. Okay? So whatever
Yes,
we did to
sir.
one side, we have to do to the other side. Is that clear?
Yes, sir.
Yes,
So
sir.
let me see if I could find another example off the top of my head. 3 plus n is equal to 9. What's n? It would be n is being equal to 9. Take this over minus 3. N was equal to what? 6. So anything in this case, I am what? Gonna take n, take 3 from the left hand side, and I'm taking 3 from the right hand side. Okay, so I have to do, when you're in grade 3, they teach you that you need to do the opposite of what you see there. So if I'm adding, I'll subtract. If I'm subtracting, I'll add. If I'm multiplying, I divide. If I'm dividing, I'll multiply. All right. So in this case, what do we see? Division. We see subtraction. So we know that we should do what? Add. So we need to what? Add to both sides. We're not there yet in class, but this is just helping us to prepare for that time. Okay. All right, the last one. I'll run through this one for everybody. In a class, the ratio of boys to girls is 3:2. What percentage of the children are boys? First, I need to add the terms in the ratio. 3 and the 2 would give me 5. So the boys would be what? 3/5 of the total. And the girls would be what? 2/5 of that
2/5 of
total.
the total.
So when we add the 3/5 and the 2/5, that's how we end up with 5/5 or the whole. Therefore, the 3/5 multiplied by 100, what 100 means again? We're dealing with what? Percentages. So 3/5 of the 100, we're going to say 3/5 multiplied by 100/1. We put the whole number over 1 to make it a fraction. We say 5 into itself one time, and 5 into 100 would go 20 times. We can't reduce anymore, so we'll say 3 times 20. That will give us 60/1. Any number divided by 1 remains the same. We get 60%. In reducing, let's remember that in reducing 5 and 100, the highest common factor of 5 and 100 is 5. Right? So we said 5 into 5, 1, 5 into 100, 20 times. And we get 60% as our answer. Any questions there?
No, sir.
All right, guys, that's it for tonight. Thank you for joining. Let's remember to review as best we can so that we can prepare for the exam. I'll see you guys in the next episode. See you guys tomorrow.
Yes, sir.
Sir.
Alright, sir.